Hey all, thought I'd do a little video on chassis measurements. Whether you're modifying a chassis, a Land Rover chassis, or you've repairing it, whether that's from rot or corrosion, maybe you've had a small accident, you've got a repairable section. You want to get things aligned pretty well as best you can. And I'm doing a lot of modifications to mine, so it's trying to keep it on point or within reason to what it should be factory wise as far as body line, angles and things like that. Obviously I've changed a lot of the suspension geometry and the mounting points, so they're irrelevant to factory. So but there's still some key things there. If you have a genuine workshop manual, and if you don't, I recommend getting one. They're handy for a lot of reasons. But if you go into the chassis and body section, at the very beginning there's some diagrams, and they're of the chassis. So each chassis is represented, that being Defender 90, Defender 110 and Defender 130 or 127 if your workshop manual's old enough. They are in side elevation and plan view, so that's looking from the side and then looking from above. Each chassis has the diagrams, and then the following page is the measurements. There's reference numbers on the diagrams, and then you reference those to the measurements that they should be. There may be a case in one of the workshop manuals, I think, where the 90 diagram and the 110 diagram are switched around by mistake. That's easily sort of figured out by the wheelbase measurement, and also if you look at on a 90, now take it into consideration that I've modified these body outriggers. This is what picks up the rear bulkhead or front of tub or rear of cab, but the rear bulkhead. They're round tube on a 90 and only on a 90. On the 110s and 130s, they're this, and in fact the 130s has two of these. 110 only has one, so that's a good way of figuring out what the diagram's doing, because a lot of the other componentries are exactly the same. So once you've figured out your correct diagram, you can go from there. There's not a lot of height measurements on the diagrams or in the information, basically. So work with what you've got. They do give, I believe, top of front bulkhead measurement, which is funny because to me it's important is the mounting hole, but they only give you the top of the bulkhead outrigger, so that's something. I think they give radius arm, they don't give trailing arm, but they do give rear cross member. Now with the horizontal datum line, which they refer to as B in their drawing, you'll see a B written on one end and a B written on the other end, and that's in drafting architectural stuff, that's BB. There's no written description or accurate detailing of what the two reference points are, because I say two because in the drawing it's touching 2 points. My interpretation is it is off the highest points of the chassis at the axles. So front axle, the curved chassis, find the highest point there where a straight point would touch, and then same with the rear axle. You've still got a little bit of curvature there, find the highest point. And the reason I say the highest point is because when you run a straight edge across those 2 points, it's only going to touch the highest points. So that's what I can ascertain as the datum line. It's pretty clear in the drawing that it's not sitting on the spring perches, and because it's lower than this, and it shows that in the drawing. So the rear is a bit hard to tell because the rear spring perch is only 5 millimeters or so higher than the chassis at that point. So the drawing's not that finitely drawn and detailed. It's pretty good and scaled and stuff like that, so it's not too bad. It's definitely better than nothing, that's for sure. I can't imagine they would have us sitting on this little gusset here, and potentially, I'm not sure. I think Rangies didn't have them or something. Maybe the very early 110s didn't have them, or maybe 90s don't have them. I'm not sure, but I'm going with it sitting on the chassis here. So at the highest point, not on these little brackets. So that's what I'm going to go with. Rightly or wrongly, I haven't got much else to go off unless someone actually knows and they can comment, which would be fantastic. The next thing is, it appears from the drawing that all the load points are parallel with that line, with that datum line. So as in for the tub and the body. And if the rear tub is at the same angle, so is the entire body line, because on the Land Rover bodies where they come up flat and then they curve in, the crease line, if you want to call it, that is one straight line, or it should be. They shouldn't go down and then flatten out and then kick and all this sort of thing. You've got it in the bulkhead, front bulkhead, through the door, rear bulkhead, front of tub, whatever you want to call it, through to the rear. So if the tub load points, which they show, the rear load point that you'll see, that's sort of on a TDI, it's different to a TD5, but they are both parallel. And then you've got a load point traditionally there, and then another one sort of, I think there was one about there, and then some more, but ignore what I've got or don't have, because I've changed all this. My cabin is longer by 200mm at least, and my cross member is 200mm further forward or shorter chassis. So they reference this measurement here below our datum line. Now I've sat mine on little packers just so the straight edge will sit there, and there's a few little interfering pieces if I was to try and sit it directly on the chassis rail itself. So I've sat it on 2 equal packers, each end happen to be 5mm. So whatever the measurement here is, which is 31.25 to 32.25, absolutely hilarious. They're talking 1/4 mil when they can barely work to 1/4 inch. But obviously I would add 5mm because I've raised my datum up 5mm, so that should be 37, which it is, thankfully. So there is not a multitude of height measurements. There's only a few. There's quite a few when you're looking in plan view from the centre line out. There's quite a bit of information there, which is good. And then on one of the following pages, there's some diagonal measurements that you can take to check that your chassis is a square. The other thing you can do is, what I work on is, I pick some points on the chassis that I always reference to check that it's level across. And I'm lucky with my chassis that, and I've picked my spring perches because they're what support the vehicle. And I've checked some other points as well, like very front cross member on the 2 chassis rails, 2 equal points on the spring perches and the rear spring perches. And fortunately, when I get it dead level across the front, it's within 1mm across the rear. So I'm just thankful that, because I've heard the stories of blokes with some of these chassis that aren't great. So again, you can do lots of checks, and I use a layout line laser, construction laser, to strike a centre line all the way down, and I work everything square off that for all my cross points. Obviously, measurements with whatever they are. So the other area you can find some information in for some measurements, there is an official Land Rover booklet, if you want, technical booklet, that was designed and supplied to coach builders. So for all the cab chassis, that is 2 or 4 doors, so mostly 2 doors in the 110s obviously, and then 4 doors in the 130, where they were supplied with no tub or anything, bare rear chassis, for people that were building different body styles, whether it be a ute tray or whatnot. It was giving them a lot of information on chassis dimensions, a few chassis dimensions, but how to mount it to meet Land Rover's engineering methodology, and what to avoid, what not to do, and things like this to stay within their design scope, but also obviously warranties and things like that. So I will try and add a photo of the diagram, just an example of the chassis diagram, and I'll also try and put in the link, in the description or below the description, some links if I can find some internet links to these booklets, if they're online. I'm not real savvy with that stuff, so if I can do it, I absolutely will, because they're great references to have. But maybe that's a little bit helpful to anyone that needs to do chassis repairs. The other thing I suggest, if you've got a reasonable chassis, or even if it's whatever, before you start cutting, set it up where you're going to work on it, set it up as best you can. Like I'm on a downslope here, but it doesn't matter to me. It's across it, and then everything is related to the chassis itself. So, and you know, I know that what angle I'm at anyway, and especially if I move it, I still know what angle that is in relation to level ground. But level across is my big thing, and then everything from there. So set your chassis up or your vehicle up as best you can. Take as many measurements that are relative to you before you cut anything off. A big thing that you will have to look out for is weld distortion as well. So once you've cut and you've installed your new piece, or you've done your modification or whatever it may be, you may tack it in and it might be beautiful, but think about weld distortion when you're doing your modifications, because all welds shrink, you know. So obviously, you know, welding across the chassis is not a good idea. It's avoided in a lot of places. You know, I've done things like this where we 45'd it to reduce stress rises, and we're doing certain things there, like I'm trying to tie this in smoothly and progressively so I don't have an abrupt change in stiffness. But the point is like a weld across will shrink and pull, and you'll get a, you know, this end will kick up. But even parallel welds will still shrink, and when you weld on the top of a box section or a tube or anything, and it shrinks, it gets shorter on the top than the bottom side. Again, it pulls up. So welding perpendicular to the length of something will always be worse for weld distortion. And also, let's say we're weld traveling this way, we will get a bit of distortion in that direction as well. I can't quite remember whether it's kicking out or in, but it's not just the shrinking up. So be aware of that. Try and balance your welding out, and you know, think about your design or how you're attaching and what you're doing. And you know, if you've got to do a replacement rear cross member, you might, you know, tack it all in position, get it right, and then say you make this outside weld first, go and make that outside weld, then this inside weld, then that inside weld. You know, keep it equal, spread it out, but keep it a methodology to it. So, you know, hopefully that's helpful. And like I said, I'll try and add some photos of the drawing, the workshop manual drawing, and hopefully I can put in the description the link to, if I can find again, the workshop booklet on mounting bodywork and tubs, because there's some good information in that as well. Hope that's helpful, guys. Cheers.